This is example 1 in section 2.11, definition of continuity. We have a piecewise function of a linear and a quadratic function where the function changes at the value x equals 3. Just to clarify and to illustrate, I've gave you the graph to the right-hand side. We can see that there is a discontinuity at the value 3, but we want to prove it. We see that there is a open hole right there. So what we're going to do is first calculate the value of the function at 3. So which function do we choose? We choose where x equals 3, and that's the function in that interval right here. So we're going to plug 3 into where x is in for that function. And I'm going to get a value of 4. So f of 3 equals 4 means the value of the function at 3 is 4, means that coordinate right there. The next thing we're going to do is step number 2. We're going to calculate the limit. Now we do have an interval where x is less than 3, and we do have an interval where x is greater than or equal to 3. Therefore, we can do left and right hand limits to see if they're equal. So the limit as x approaches 3, on the left, I'm going to use the linear function, 3x minus 2. Use substitution, plug 3 in. I'm going to get 9 minus 2, which is 7. I'm going to perform the right-hand limit, and I'm going to use the quadratic function and substitute the value of 3 in, which I know is 4. Now the left and right-hand limit are different, which means the limit does not exist. So the limit as x approaches 3 of this function does not exist. And if the limit doesn't exist, we know that we have a discontinuity. The third step, just to clarify, the third step is when f of 3 should equal the limit as x approaches 3. Should, if it's continuous. But we know that the limit doesn't even exist, so how could it be equal to f of 3? So we're going to say it does not equal. And then we're going to say what type of discontinuity it is. So because the limit doesn't exist, this is called a non-removable discontinuity. And it's because the limit doesn't exist. Since the limit as x approaches 3 does not exist. And again, non-removable is just the type of discontinuity it is. I see here that I have a hole, and I also see that I have a function that's defined, but there is a gap between the two. So it's almost like a jump discontinuity. But again, we only have to be concerned with the name non-removable. So when you say it's discontinuous, that's another way of saying it's not continuous.